Hi guys, haven't made a video for a while, but I've been meaning to show you this for quite some time. This is based on the work of John Martineau's little book, A Little Book of Coincidence in the Solar System, well worth a read. So what I've done is to see if he's right in what he says. I've gone to Wikipedia, I've taken the orbital speed of each planet and its time that it orbits the Sun, and that gives me a circumference that I can plot, give a mean orbit. Right, so what I've done here is with these, for example, this Mercury orbit here, the center one is the mean orbit, so that's the actual distance. The other two lines are the apsis, well, that's the right term, I think. So how close it goes to the Sun and how far away it goes from the Sun, because it's actually travelling in a big ellipse. You can see with the Earth one, it's a lot smaller. So the elliptical path around the Sun is not as pronounced as Mercury, for example, and Venus is almost a perfect orbit, whereas Mars has got more of an elliptic orbit, so it moves closer to the Sun and further away from its mean orbit. But what we find is that with Mercury's orbit, if we plot 3 circles just touching each other tangentially, then the tangent of those, the outer tangent of those circles, fits perfectly in Venus's orbit. If we take a pentagram and plot it inside Earth's mean orbit, then we'll have 2 things fitting here for Mercury. One, the crossing points is Mercury's mean orbit, and it's what's that, periapsis, how close it goes to the Sun. That orbit fits within the pentagon within the pentagram. If we plot a square on Earth's what's it called, apoapsis. Anyway, Earth's apoapsis, we'll find that will fall the inside, so inscribed within the square will be Venus's periapsis. Now these are just the 3 inner planets. This kind of geometry goes on right on out. Let's turn on some other stuff. So out here, if we take a triangle within Uranus's mean orbit, then Saturn's mean orbit inscribes within that triangle. And more layers here. Where are they gone? There we go. He also describes how a 15-pointed star, so I'm assuming is that one, in Saturn's mean orbit will inscribe Earth's orbit. It's pretty amazing. It seems that Earth is the maybe not the centre of the solar system, but the geometrical centre of the solar system. Now this is an 8-pointed star. Here we find Saturn inside Saturn's mean orbit, the crossing points of the 8-pointed star falls on Jupiter's mean orbit. Now that the accuracy is, it's not perfect, but it's in the high 90s. Most of the time it's in 99.5% accuracy. What else have I done there? Also found that with a pentagonal recursion, starting from the inscribed mean orbit of Earth, then we find pentagonal recursion falls on Mars's mean orbit. It seems to fall in a lot of the orbits, not in a highly accurate way, but enough to be of interest. Anyway, we find that this pattern is not only two-dimensional, it also occurs three-dimensionally. Such as in Martineau's book here. Find the orbits of Earth and Mars, sorry, to be a dodecahedron and an icosahedron. I've also plotted out planets in a three-dimensional shape that you might like to see. So thanks for watching.